Hey everyone, welcome back to my YouTube channel Summarized AI. As part of this video, we are going to talk about in-memory store we have in LangChain. So in-memory store is a simple temporary memory store in LangChain that keeps data only while your program is running. It behaves like a Python dictionary under the hood. It implements the generic store interface, put, get, delete, etc that LangChain tools and agents use. Once your program ends, all the data we have in that memory get lost because it is stored only in memory, which is our RAM. As part of this blog, we will see what is in-memory store, how it works, and its implementation. So let's proceed further. Let's try to understand in-memory with one of the example. Here, our agent having three main components: an LLM model, a set of tools, which is nothing but functions for making calls, and a store, which is nothing but a in-memory store. Now, our agent will make a query to save user based on the user details. It will call save user info tool, which is a method will help us to save user inside in memory store based on the user ID. Now, agent will again make another query to get user based on user ID. Here we have a custom tool as get user info tool, which will get trigger and allow us to fetch user info from memory store based on user ID. And this is how the in-memory store works end to end. Now let's go ahead and see the implementation. Now, quickly let's try to understand the use case we are going to implement as part of this video. We require an agent having LLM to understand query, some tools to take actions, and a store, which is a temporary memory to save important stuff. In this next step, agent will invoke query and find out suitable tool based on query. Now it will automatically fix the save user info tool to store the data in-memory store. Now the same agent will invoke a query to fetch the user information based on user ID. The agent will understand the query and fix the get user info tool. The tool looks into the in-memory store to find the data and return the same if user is found, else return no user found. Here, the store works across all calls, so whatever you save once, you can fetch anytime later, as long as the app is running. Now, let's create a file and say memory.py. Okay, and before we start our implementation, we require some library to be available in our local. So the very first one is pip install LangChain. Now we require one more library, which is pip install LangChain underscore OpenAI. We can hit this also in our terminal or command prompt, whichever you are having. Okay. Now the library is installed and you would be seeing this message requirement already satisfied because I'm already having these libraries in my local. You might not be seeing if you are installing or downloading these libraries first time in your local. Now, apart from these two libraries, we require one more library, which is LangGraph. So we can say pip install LangGraph. We can go ahead and hit this also in our terminal, pip install LangGraph. We are having this. Now we can go ahead and start our implementation. So we can say from typing import any. Okay, so we are going to use this typing to check the data type. Now we can import the in-memory store, and in-memory store is a class that stores data into RAM for quick access rather than storing it in file system, Redis or PostgreSQL. So it is a kind of temporary memory. That's what we discussed. So let's import it from langgraph.store.memory, import in memory store from LangChain.agents, import create agent. Now we require tools also. So we can say from LangChain.tools, import tool. Now here we require one more library, which is tool runtime, allows the tool to access memory, user context, or other runtime info without hard coding it. Great. Now we require from LangChain OpenAI, import chat OpenAI. Okay, great. Don't worry about these imports. I will be explaining each and everything step by step. So let's go ahead and create our tool here. And just for information, if you don't know what tool is, how it works, you can go ahead and watch my earlier video where I have provided the complete end-to-end overview on tool. So let's create a tool, and tool is nothing but a function. So tool define get user info. Okay. And here we are saying get the user info based on user ID. So user ID, which is nothing but a string. And then we have runtime, which is nothing but tool runtime. Great. And it is going to be string. Now this is there, and we can type a doc string here, which will provide the more context to our LLM. So we are saying lookup user info from memory. Great. Now we are having this tool runtime here. We can say runtime dot store. It will give us the store. Okay. Now, once we have this store available with us, we can fetch the user information from user. So we can say user underscore info equals to store dot get, and inside it you can say users, comma, and after this you can say here user underscore ID. Now you can return the user in the form of string. So you can say user info dot value if user info is available. Else you can say unknown user. So this is the way you can get the user based on the user ID from the store. Great. Now let's create one more tool, or I would say one more function here, and which will allow us to save the user info. We can say save underscore user underscore info. Here we are passing again the user ID as string. Okay, and then we have user underscore info, which is nothing but a dictionary. Okay, and this dictionary is going to have a key, which is a string, and any. So here we have imported this from typing import any, and any is nothing but it denotes to the data type. So the value what dictionary is going to have, it can be of any data type. It can be integer, string, float, object, anything. Great. Now, once we have this, at the end we require this runtime again because we are going to save that user inside tool runtime. Great. This is we have here. Now, at the end of the day, we are going to return the string. Great. Now, here also we are going to provide the doc string save user info into memory. Now enter, and again you can say here runtime dot store. Now it is going to store in store itself. Great. Now we have this store available, and we do understand whatever user we are going to get, we are going to store that user into this runtime store. Great. So let's do that. So store dot put, provide the users here, then comma based on user ID, and then user info. Great. And in the return, we can say simply successfully saved user info. Great. Now, what we can do here is we can create the object of in-memory store. Now, why we are going to create this object of in-memory store, we will see later. But let's create it. Okay. So we are initializing this in-memory store here. Now, if we proceed further, we require a model, correct? Model can be of any OpenAI or Cloud A or Olama because we are using Chat OpenAI here. So we are going to get the model from the Chat OpenAI. So this is Chat OpenAI, and pick one of the model. You can say model equal to, I'm going to use GPT 4o. Okay. This is the model I'm going to use. And then with the model, we do understand we require a API key. Now, how to create the API key? I have already created a video. You can go ahead and check that video. I am getting this API key from here. Now we have the API key. Now we are going to create an agent. Agent equal to create agent. And here you can pass the model. Now after model, we also require tools. So whatever tools you have created, provide those tools here. Get user info and then save user info. And apart from this, we also require the store. So you can say store equals to store. Great. Now, once we have this agent, we can invoke this agent, and this agent will make a query to this model using this tool. From this store, it will allow us to fetch or save or fetch the user. Great. Now, let's say agent dot invoke, and then you can say this here, messages, and then again this thing here, and you can say role. Role is going to be a user. Then you have to provide the content where we are going to pass our query and say save the following user colon, give enter double quote user ID. Here you can pass the user info. So I am already having this user info available. I can copy paste and keep it here. Now this is our one of the agent will allow us to save the user information, and nothing we are getting in response. We are not expecting anything. Now once we have this, what you can do, you can copy paste this agent below. Okay. And in the content section, you can say get user info for user with ID user 123. Okay, great. Now assign this to response. And here you can say messages equals to response messages. And at the end, you can print that particular messages here. Messages dot content. Great. Now let's go ahead and try to execute the code. Now first it will execute this, save the user info, and then we will try to get the same user info here. And if you have seen, we have created an agent, okay? And in the agent, we have passed the model, which model to use, okay? And with the model, we have passed the API key. we have passed the tools, like when you are saving or fetching the user, use these tools. Okay, use these methods. And if you have more tools, you can provide all the tools, comma separated here. Now you have given this store here. Now it is using this particular store to have read and write operation. So as soon as this agent having all these three information will make this query save the user info, then it will call this particular code save user info, and then it's in save user info you are getting this runtime inbuilt, and this inbuilt runtime is having a store. So in this store you have put your user information, okay, and then when you're again running a one more query to get the user info based on user ID, then it is accessing this tool get user info, and with the help of get user info tool, it is fetching the user detail based on the user ID what we have passed. And this is how this particular in-memory store is working. Now, if you see the output here, the user information for the user ID, user123 is as follows. So we are able to get the user info using our LLM model. So it is providing the response in the natural language processing, which is NLP. And that's it we have for in-memory store.